So we're going to end the first day of our cardiovascular review by talking about the baroreceptor reflex and other ways that we maintain blood pressure. Okay, so here are 3 objectives for the day. So we're going to start off by talking about the baroreceptor reflex. Okay, blood pressure is under reflex control. That's good. It means you don't have to think about it. It just kind of happens. All right, remember, blood pressure is sensed by baroreceptors, and these baroreceptors are found in the carotid bodies and the aortic arch, okay? So right where blood comes out of the ventricle into the aorta. This is good because if there's an issue there, there's going to be an issue everywhere. Now, there's also chemoreceptors and mechanoreceptors involved with this reflex, okay? And so this kind of explains what's going on. I haven't given you a lot of detail because this should be review, but just think for a second if you stand up. All you're doing is standing up. Where's blood going to go? Well, it's going to go down to your, to your big toe, right? I love talking about my big toe. So here is my person. I'm standing up. Okay, there we go. Yay. So blood's going to go down here. So what happens to my pressure? My pressure is decreased, all right? And so I need to do things that will overcome this low blood pressure. And so what happens is I'm going to increase my sympathetic nervous system, and I'm going to decrease my parasympathetic nervous system, okay? And what this does is this causes increased TPR, stroke volume, and heart rate. And remember, the parasympathetic only deals with this one, whereas the sympathetic deals with all 3 of them. That says TPR. This is horrific. Okay, and so that's the reflex control. If I have high pressure for some reason, the reflex is going to lower it by doing the opposite of what I've written here. So when I stand up suddenly after watching football on my couch all day, blood rushes to my toes. I get a little lightheaded because pressure is low, and so it takes a few seconds for pressure to get back to normal. So what are the issues with being upright? We've kind of just answered them. But you have to remember, gravity plays a role. Okay, it's going to cause pooling down in my lower extremity. And just to reiterate, pooling makes it sound like blood's just hanging out there not doing anything. That's not the case. It's just that just means we have more than normal. Okay, it's still moving, maybe not quite as fast though. So the problem with that, if it's down there, it's not going up to my brain, it's not going back to my heart. Right, it's not necessarily getting to places where I need to go. So now let's tie this into exercise. And even with just standing there, there's an issue. But let's tie this to exercise. Okay, when I exercise, I need more blood. But in order for my heart to pump more oxygenated blood, I have to return more blood back to my heart. And so one of the ways that we accomplish this is versus the skeletal muscle pump. Okay, and so this is my Gogurt analogy. This was actually given to me by a student that's still here on campus. Her name's Harley. And basically think of your blood vessels as a Gogurt and your muscles as your hand. Okay, so if I give my kids a Gogurt, and what do they inevitably do? They end up squeezing it really hard in the middle. Well, when that happens, that's like we're increasing pressure inside that blood vessel or that vein. That causes blood, or Gogurt, to go up, all right? And this is good, at least when it comes to the skeletal muscle pump. With Gogurt, not so much because there's going to be a mess, all right? And so that's what's happening. Your muscle contracts, it squeezes the vein, blood goes towards the heart. It doesn't go down towards your lower extremity because, as you can see here, we've got valves. And these valves are one-way valves, and they prevent the backflow of blood, okay? And so as a result, every muscle contraction pushes blood towards the heart, keeps pushing, and that helps get blood back to the heart, or it increases venous return. And so exercise, something where we need more blood flow to make it so we can exercise, is actually facilitated by the fact that we're exercising. Another thing that allows us to help get blood back to our heart, increase venous return, is through the respiratory pump. So the respiratory pump, there's 2 parts to breathing. So you've got inspiration and expiration. Different things are occurring during inspiration. So during inspiration, diaphragm pushes on the internal organs, causes abdominal pressure to be greater than thoracic pressure. So we've created a pressure gradient, flow down gradients, and so now it makes it easier for blood to go from the abdominal cavity up to the thoracic cavity. Okay, so this helps get blood into my heart and into my lungs. So we're increasing that venous return. But because it's going just into my heart and into my lungs can actually open up more capillaries to take this sudden rush of blood. My left-sided stroke volume actually decreases. Okay, so we're getting lots of blood into my right side of the heart and my lungs, but that blood's not leaving yet, or not leaving as quickly. And so this is where expiration comes in. So inspiration gets it to my heart, expiration gets it out of my heart into the rest of the body. Because what happens is the exact opposite. The diaphragm relaxes, I've switched the pressure gradient, and so I'm in essence squeezing blood out of my lungs into my left ventricle where it is then pumped throughout the rest of the body. During this time, because the pressure gradient is going from thoracic to abdominal cavity, I have reduced venous return. But I have higher stroke volume, so I can take care of get blood to my muscles. Now, if you're thinking about it from inspiration to expiration, I'm going to have a greater stroke volume during expiration than I am during inspiration. However, this all balances out. We don't want them to be imbalanced, but beat to beat or breath to breath, there might be some imbalance as to what is leaving the right side of the heart compared to the left side of the heart. And so we're going to end with that.